Assalamualaikum. Good morning. Can you hear me? Can you hear me?
Okay.
Chung Hoi Ki. Chung Hoi Ki. Dah datang? Dah datang
Doktor.
Ivan.
Dia pergi tandas.
Okay, Ivan. Can you go to this the last one, 29 April 2020, test one. The last one. Can you read the question, please?
Unity feedback system is shown in figure Q1. Given that GS from the given output loop transfer function GS, determine the following: the imaginary closing of the root locus of the closed loop transfer function, hence the gain at that closing.
Lagi?
The arrival angle of the root locus of the closed loop transfer function. The breakaway point of the root locus of the closed loop transfer function is given as s equal -6.05. Hence, determine the gain at that point. Using the information gathered from 1 and until 3, sketch the root locus of the closed loop transfer function. Hence, determine the range of gain k for the underdamped stable system and the critically damped system.
Okay, so this one is question number 2. Okay. This one Q2. Okay. Okay, let's go to the question 1. Imaginary crossings of the closed locus of the closed loop transfer functions. Okay. So we were given this one. Okay. If I go to this. Right? Okay, so how are we going to find the cross sections of the root locus with the imaginary axis? Root locus is not given, correct, Ivan? Root locus is not given. Any idea? Zarif?
Yes, Doctor.
Any idea? Any discussion?
No, Doctor.
Bagilah idea. Bagilah idea.
No, Doctor.
No. So given open loop transfer function. Okay. So it's G K S square minus 4S plus 8 S plus 4 S plus 10, correct? So G is equal to K plus 8 S square plus 14S plus 40. So how are we going to find the closed loop? Zarif? Tak tahu. 1 over 1 plus G lah. G over 1 plus G.
Plus G.
Okay. So T is equal to K S square minus 4S plus 8. Okay. S square plus K plus 1 S square plus 14 minus 4K S plus 8K plus. Okay. Shahin, what is the characteristic equation? Yang ni lah.
Yes, bro.
Yang ni.
The bottom
Equal
one
to
equal to 0.
0 is the characteristic equation. Okay. So insert the coefficients of characteristic equation to RHT. What is RHT? Omar, what is RHT?
Yes, Doctor.
Hmm.
Roth H table.
Huh? Routh Lewis table.
Yeah.
Routh Lewis table. Okay. So the RHT is okay. So K plus 1, 14 plus 4K, 8K plus 40, 0, 0, 0. Okay. So continue to this one. So what is the continuations? This one. Wenjin.
Yes, Doctor.
Hmm.
Kita found the determinant of
Ah,
the okay.
K plus 1.
14 plus 4K and 0.
Okay. Divided by.
14 plus 4K.
So we get back K plus 14. Okay. So First column of Rothway's table. Okay, what is the first column here? First column here is K plus 1, 14 plus 14 minus. Okay, and 8K plus 40. So this is the first column. So mass greater than 0, greater than 0, greater than 0. Okay. So you simplify the three coefficient. Yeah.
Yang tadi tu 14 tambah 4 bagi
14.
table.
Okay. 14. Divide by 14 plus. Oh ni. Ni bagus. Siapa nama awak? Nama?
Irfan.
Irfan. Tak tidur bagus. Irfan tak tidur, very good. Yang lain semua tidur. Okay. Lepas tu kena buat face to face lah. Dia kan dah bising, kena buat face to face juga. Semua dah manja. Lemak dah tebal lah. K greater than 0. Simplify, so kita akan dapat K less than 3.5. Dan 8K plus 40 greater than 0. So K is equal to greater than 85. So it seems that the range is here. Okay, so automatically we can understand that the range of K for stability is 0. Kita ambil positive number, 3.5. So if K is equal to 1, Chung Hoi Ki, stable, not stable, marginal? Stable. K equal to 5, Chung Hoi Ki, again?
Not stable.
Not stable. Ayo, halo. Puasa ke? Macam puasa je. Puasa malam. Oh, puasa malam. Okay. 3.5. San Kuai Liuk. San Kuai Liuk pula. San Kuai U. 3.5. When K equal to 3.5, what happened? Marginal mah. Tak faham lagi lah tu konsep. Okay, so please understand the concepts, right? So now we want to find what is the cross sections between the root locus and the imaginary axis. Therefore, we know the K critical, or we call it as K crit lah. K crit, crit. And then apa nama ni? We go to the root table. Where is the even equations? So the even equation is located here. Okay. Chong Hoi Ki, can you remember this? Because I have to write. Boleh? Boleh? Okay. What is the even equation, Chong? Okay. Plus 1 plus 8K plus 40. Okay. So insert K critical there. 3.5. Insert inside. So you will get 4.5 S square plus 68 equal to 0. Okay. Then simplify S is equal to plus minus J 3.89. This is equal to j omega. So omega is equal to 3.89 radian per second. So this is the point where RL intersect ITC, intersect j omega axis. Dia faham tak? Understand? Ni, faham tak?
Setakat ni boleh lah doktor. Slow-slow.
Demo faham tak? Ambau terang ni, demo faham tak? Faham bagus. Alhamdulillah. Okay. So what is the next questions? The next question is panjang soalan. Nama. Oh, the gain. What is the gain crossing? Gain is 3.5. Yeah. Arrival angle of the locus of the closed loop transfer function. All right. Theta arrival. Why theta arrival? Why? Why not theta departure? Hadif.
Ya, doktor.
Why theta arrival? Why not theta departure?
Sebab
English. We have
because
Arab
of
brothers.
break-in point.
Because of break-in point. Astaghfirullah. Besar doktor. Allah tu. Kon. Why we have to calculate theta arrival? Why not theta departure?
What is for
Cakap kuat sikit mah, tak dengar.
theta is for pole?
Can't hear you lah. Puasa kan? Kuat sikit.
Theta arrival is for poles.
Theta arrivals is for poles. Theta departure is for
0.
terbalik mah. Theta arrival is for zeros. Theta departure is for poles. So we have one pair of zeros mah. Ni -2 plus J2 -2 minus 2J. Salah jawapan awak. Apa? This revision ni mesti ada salah. During test jangan salah. Okay? Boleh? So Simichin, what is the method to find the theta arrival?
180 degree minus the theta for -4 theta 1 and theta 2
Then
and theta 3.
sini lah theta arrival. You nampak? Can you see what I'm writing here?
Yeah.
Clear? Very clear? Okay. So what you say just now, Simichin is use angle criteria lah. Am I right? Angle criteria kan? So from this poles is theta 1, theta 2, theta A and theta 3 is the due to the zeros kan? So theta 1 plus theta 2, okay, minus theta A arrival plus theta 3 equal to 180 degrees. Okay, so that's why theta A is equal to so what is theta 1 and what is theta 2? Diana, Camelia, theta 1 and theta 2. Tak datang. Natrah. Natrah pun tak datang. Atikah?
Ada tak?
Nyaut tak datang, absent. Tak nyaut, absent. Natrah.
Ya.
Theta 1.
Theta 1
Ni.
dan
Ni theta 1. Berapa?
tangent inverse
Mhm.
uh,
Betul lah.
over 2
Dua. Over 12. Theta 2.
theta 2 tangent inverse
Mhm.
2 over 6
Over 6 minus 1 is 0. Theta 3.
theta 3
Okay.
90 degree
90 degrees. Betul. Itulah power, kan? So theta rebel is 117.9 degrees. Okay. Okay, guys. Boleh? Okay, number 3. Liana Kamalia. Datang. Ismail. Ismail.
Yes, doctor.
Number 3, please.
The breakaway point of the root locus of the closed loop transfer function is given.
Is given. Okay.
Determine the gain at that point. The length from each pool.
Mhm.
The length of the zeros over the length of the pools. So
has a formula.
The formula, I think,
S plus 4 magnitude. S plus 10 magnitude. S square minus 4S plus 8 magnitude. Replace with minus 6.05.
Yes.
So become Haza.
Okay, just a second. Zero.
I use my calculator, my head.
Okay.
Correct.
Just a second.
This one is easy because there is no imaginary part. It's a real part. So you just replace 6 minus 6 minus 6 minus 6 minus 6 minus 6. Then you get it.
Oh, I got a different answer. I got different answer. 1.8.
The true is 0.1177. 0.12 lah. Never mind. It's okay. You can check again. Okay.
Okay.
So using the information gathered from 1 and 3, sketch the root locus of the closed loop transfer function. Sketch. So mana gopernya? Mana gopernya, Yob? Wan Muhammad Alimi. Mana gopernya? The sketch.
Ya, Doktor.
Tak datang. Local sketch. So here, start from pose. Okay, then break away. Pen. Okay. So this is the minus 6.05 breakaway point. Okay, and this is property, the intersections. $3.89. Okay, so this is the sketch one. Yang pun tak datang. Hence, determine the range of gain K for underdamped stable system and critical dam system. So we just list out lah dia punya tu. For underdamped stable system. $3.5 and critical dam system is when K 0.118. Okay. Out of the range is unstable. Okay. Okay, so we move to the next question. Nurul Atika, bacakan.
A closed loop unity feedback system, as in figure Q2.1, has a root locus as shown in figure Q2.2. First, design a PD controller to yield a damping ratio of 0.59 with a threefold reduction in the system settling time. Second, for the compensated system, determine the peak time and the steady state error. Third, sketch the step response of the compensated system.
All right. See, the PD is 12 mark. So, Tika ada printer tak? Do you have printer at your hostel?
Oh, tak ada.
Your roommate?
Tak ada juga.
So how are you going to use the protector? How are you going to use the protector for 0.59? Berapa ni Tika? Tita?
$53.84.
Okay. So I advise you, all of you lah, buy a printer. So you have to print this one. Otherwise, how are you going to use protector without printer? Jason Lau?
Yes. Okay.
How are you going to draw the zeta line? Because you have to attach this in the final exam answer, the printout. So you don't have printer, how are you going to do it? To draw the 53.8. Jason? This tak tahu. Denson? Denson faham? Tak tahu. Si Michin, how are you going to draw the...
I got printer.
You got printer mah? Ya. Pinjam mah, pinjam. Listen.
Huh?
You pinjam mah, you pinjam si Michin punya printer mah. Okay.
No, actually I have a printer as well.
So why you so quiet? Just now I asked, wasting my time ah.
Okay,
Tidur
sorry.
puasa tidur.
Sorry.
All right, no problem. Okay, so what is the dominant pole? So if you print and then you get this, okay, using the protector, dominant pole. Minus 1.8 plus J 2.2. This is very important. Okay, so if C Michin got 1.85 plus J 2.2, Nurul Atika got minus 1.7 plus J 2.0, also okay. Okay, also okay. Okay, don't worry. Okay, because design the value can be not the same, but almost in that range of acceptable. Okay, but if you find, if you give the dominant pole sepak plus J 22, of course this one is wrong. This one is right lah. Okay, this one is wrong. Salah tengok. Okay, so must be in the range of acceptable range. Okay, so dominant pole is there. So actually the question one. Three, four reduction. Okay, understand. So you have to play with the settling time. Settling time 4 divided by real. Berapa? 1. Okay, kan? Ni. Berapa ni?
Yeah. 2 point.
3, 4 reductions.
0.74.
Go ni. Pantah demo ah. Okay. Left. Then what is the real new? Real new is 4 divided by huh? 5 point?
5.41.
Okay. Okay. Gradient. Okay. And from there, you can get the imaginary new. Okay. $9.5 1 pi, 1 minus, which is J
7.39.
Thus, okay. So what is the new dominant pole? Yawen, what is the new dominant pole?
8 plus J 7.39.
Come again?
1.8 plus J 7.39.
Huh? Wrong, man. Chongjuan, what is the new dominant pole?
5.41 plus J 7.39.
Minus 5.4.
Okay.
Okay, that is the new dominant pole. So after that, Ashraf, after that, what is the next step? Ashraf tak datang. Asnawi, what is the next step?
I'm not sure.
Not sure. Aduh, tak fokus. Noraina, what is the next step?
Also not sure, Doctor.
Stop. Apa nak jadi tu? Divarajan, what is the next step?
Cari poles dengan zero.
To find the value of zeros. Divarajan, you have to speak in English because we have Arab brothers.
Sorry, Doctor.
We have Arab brothers over here. Okay. Arab brothers, can you understand Malay? Sikit-sikit.
A little.
A little, huh? Okay. We have to find the zeros value, which is this one. Okay. Because PD, we introduce a new zeros to the transfer functions. Okay. So what is the magnitude criteria for this diagram? Chua Leong. Chua Leong.
Doctor.
Angle criteria. Theta 1 plus theta 2 plus theta 3 minus theta 4. Well, sure.
Yes, Doctor. Yeah.
So what is theta 4? Theta 4 is okay. So theta 4 is 97 degrees. Okay. So 97 degrees is yes. Okay. So we have to find this one. Right? We have to find the angle so that we know the distance between minus Z and minus 5.4. Okay. So tangent okay. So soft X and then you get minus Z is equal to minus 4.49. Okay. So GPD is equal to K S plus 4.49. So how you get the K? How you get the K? Okay, so you insert the S value. The S value is the new dominant pole, okay, which is minus 5.4 plus J 7.39. Ismail, what is the value of K?
Sorry, doctor.
The value of K. The new dominant pole insert inside the magnitude criteria.
Okay.
So using your calculator, so you get 89. Okay. Okay. Then what is the second question is the peak time divided by imaginary. .39. Okay. System is type what? System. Type 0, type 1, type 2, type R. Safwana. System type. Safwana. Safwana tak datang. Haris Haikal.
Yes, Doctor.
System type dia apa?
Not sure.
Tanya burung. Haris. Oh, Haris.
Ya, Doctor.
Tanya burung. Berapa system type? But this is the open loop transfer function based on the root locus. Okay, because the GS is not given. Okay, so you have to derive your own GS based on the plot. So this is the GS, and S power of 0 is there. That's why the system type is 0. Okay, so if the system type is 0, so Kp is equal to limit S to 0, 89, S plus 4.49, S plus 1, S plus 3, S plus 12. Okay, 110.9. So the steady state error is 1 plus Kp 0.009, almost 0 lah. Almost 0. Okay. Almost 0. So the sketch will be like this. So this is the input and the output. And the peak time, which is 0.43 seconds. And the settling time tadi berapa, Atika? New settling time. 3-4 reduction tadi berapa?
0.7.
0.7. 7.4. Any question, guys? Any question? Okay. Any question?
No, Doctor.
No. No. Nur Hazika? Nur Hazika Shazwina?
Doctor, I
Ada
have a
soalan?
question. Hello, Doctor.
Nur Hazika, ada soalan?
Tidak.
Ya ada. Hazika?
Tidak, dokter.
Hazika, I have one question for you. What is the damping category of this system, Hazika? From the response, damping category.
Under 10.
Under 10. Betul bah? Betul bah? Betul. Okay, no question. No question. Nur Hazika, can you read question? This question, please.
Sorry, Doctor.
Yeah. Oh, yeah, the question. Okay, Mukri.
It seems like you use like 2 decimal places, isn't it? So for
two
the
decimal
test
places.
and for the test, should I use 2 or 4? Or 2? Okay, thank you, Doctor.
Peace, you. Peace.
Peace, Doctor. Okay, thank you.
Okay. Nur Hazika, can you read question? Second last questions. This one. Nih,
Mana, dokter?
tu yang I circle tu. Because on this 2019-20, we have 2 set because it's online. First set for those free of is not is negative for COVID, and second set is for positive COVID. Okay, so that's why we have set. Can you read this question, please, Hazika?
A unity feedback system is shown in figure Q1.1. The root locus of this system is depicted in figure Q1.2. From the root locus in figure Q1, determine the following. First, the forward transfer function. Second, the asymptote point and the asymptote angle. Third, the angles of departure of or arrival for this system. If the system is operated at 10% of overshoot, identify the following. First, the dominant closed loop pulse for this case. The operational gain at this point, verify the validity of the second order approximation. And last, for a step input response, determine the setting time, the peak time, and the steady state error for this design.
Oh, Sabah di mana?
Papar.
Papar. Okay, guys, we take a break for 10 minutes. Boleh? 10 minutes break.
Boleh, Doktor.
Sure, Doctor.
Okay, continue. Guys, are you there?
Yes, Doctor.
All right. Question 1. All right, so from this question, again, GS is not given. Okay, so what is GS here? The open loop transfer function. So we read from here, from the plot. Okay, we read from the plot. Open loop 0, open loop pole. Okay. So open loop 0 is -3, and open loop poles is -4, -2 plus minus J1. Okay, and from here we construct the open loop transfer functions. Okay, which is S plus 3. Okay, S plus 4, S plus 2 plus J1, S plus 2 minus J1. Okay, and then so we got the S plus 3, and S plus 4. Okay. Right. So this is the open loop transfer functions. Okay. Forward transfer functions. Yes. Asymptote point and asymptote angle. So part 2 is the asymptote point, which is a A1 minus 2 minus J1 minus 3. Number of poles is 3, number of 0 is 1. So you get minus 2.5. Okay, so that is the sigma A, the asymptote point, and then angle of asymptote. Okay, so we have 2K plus 1, 180 degrees, the formula. Number of poles, number of zeros. So 90 degrees and 270 degrees. Okay. Then angle of departure. Angle of departure. Angle of departure. Safwana, why angle of departure? Why not angle of arrival?
Yes, Prof. Don't know.
Don't know, aduh.
Sorry, Prof.
Angle of departure. Sorry, angle of departure occurred at complex conjugate pole. Ni complex conjugate poles. Delta of departure lah. Ya, dia punya sudut berlepas tu. Angle of arrival, like the previous test just now is occurred at complex conjugate zeros. Itu yang zero tu kan. Complex conjugate zeros. Ni tahu tahu. Ish, sudah ni. So, angle of departure. Okay, angle of departure. So we have to draw properly. Okay. Right. And okay. Then okay. This one is okay. So okay. Right. So draw it and then write the formula, which is theta 2 plus theta 3 plus theta 4 minus theta 1, 180 degrees. Okay. So theta 4 tu actually is the theta theta departure lah. Okay. So theta 1 is 45 degrees. Theta 2 is 53.69 degrees. And theta 3 is 90 degrees. Right. So theta 4 you get 101.31. Okay. Which is theta departure lah. Okay. Degree. Right. If the system is operated at 10% overshoot, identify the followings. Okay. So 10% overshoot, you go to the lampiran attachment of the questions. Oh, just give this one. Okay. So you use this formula. Okay. You use this formula, 10% you insert inside. So you get zeta 0.59. Okay. Can? Can? Okay. Can? Video. Zul help me? Can?
Okay.
Okay. Use formula. Right. So overshoot 10%. So which will give you zeta 0.59. Okay. Omega n, ada tak? Omega n. Okay, tak ada. So maknanya so you have to find the theta first. Berapa? Zul help me?
F 53.84.
53.84. So print this one. Okay, print this one. Okay, 53 something like this. Okay. theta. So this is the dominant pole. Okay.
Betul.
Right. Yep.
Dia ada tanya pasal angle of apa ni? Asymptote tu. Satu tu. Sebab P minus kan
K ni. You replace K is equal to 0, 1, 2. Itulah formula tu.
Oh tak, no, sebelum lagi dah.
Sebelum
lagi.
Ya, ni.
Yes.
Ini is a asymptote point. Kenapa?
Kan 3 tolak 1 kan. 3 tu tahu yang 1 tu mana datang tu.
Ni.
Yang mana?
Minus 2 plus J1 minus 2 minus J1. Dia datang daripada sini. Plus minus J1.
Denominator tu.
Denominator. Ini number of open loop pole.
Okay, faham.
Ni number number of open loop 0. Okay? Dia saya pakai ini lah. Macam ini senang. Alright.
Okay, thank you.
Okay, thank you. Right. Okay, so 53.84. So kita dapat dia punya dominant pole, root locus, intersection 0.59. Minus 2.41 plus J. Okay. And what is the gain here? Smile. K, the gain value at the dominant pole. Smile.
Yes,
the gain value at this dominant pole. If MATLAB, you use the mouse and then you scan cross section, but now in calculations,
we insert this point in the transfer function.
Okay. Into the magnitude criteria. Okay. So you get 11. 11, Sheikh?
All right. Yes.
What is 11 in Arabic?
11.
11.
11.
11. Okay. Characteristic equation is S cubic plus 8S squared plus 21S plus 20 equal to 0. Okay. Why we have to use characteristic equation? Because we want to verify the second order approximation. We want to find the third pole. Okay, so K is equal to 11. Okay, so insert inside. So you will get 0. Okay, then find the roots. Sami, what is the roots, Sami?
Yes, doctor. Calculating.
Calculating, please. 3 point. Wow, so long, Sami. Okay.
Yes, the same, doctor.
Same, huh? Okay. This is the dominant pole. And this one is the third pole. So how to do the validation of the second order approximations? We have to find the ratio. Find the ratio. Ratio. Which is the third pole divided by real part dominant pole. Okay. So 3.18 divided by this one, 2.4. So the ratio is how much? Semi 3.18 divided by 2.4.
1.325.
1.325, which is less than 5. The rule of thumb said greater than 5. Second approximation is valid. Less than 5. Second approximation, second order approximation not valid. Okay. So is it valid or not valid?
Not valid.
Not valid. Okay, not valid. Those who said not valid, raise your hand using Zoom. Raise your hand using Zoom. Not valid. Raise your hand. Faris. Okay. Tak tahu entam je lah. Jensen. Si Micin. Semua kata not valid. Okay. Yang lain tak tahu. Actually the answer is valid. Okay. Valid. Why? Why? If we see the answer is valid, second order approximation, even though ratio less than 5, but higher order poles, which is minus 3.18, cancel the close loop 0 at minus 3. So you have a pole minus 3.18, which cancel the 0 at minus 3. So it seems that it near together lah. It near together. Okay. This is minus 3.18, and the zeros is minus 3. Okay. So this one can be cancelled out each other. So when cancelled out, the behavior is like a second order. So that's why second order approximation is valid.
So doctor, if they're close, they just cancel out each other.
Even though ratio less than 5. So what's the question? Sorry, come again.
The reason they cancel out each other.
Because if you look at the plotting, 0 minus 3, and the third pole is minus 3.18. And then the rest of the system, -4, -2 plus minus J1 kan. Okay, minus J1. Okay, so this one can cancel. The third pole can cancel this 0. Okay, macam inilah. S plus 3, S plus 3.18. It's very near. It's very near and it's overlap. So we can cancel this one. Okay, that's why second order approximation is valid. Did I answer your question?
Yes, doctor.
Thank you. Then the last one, for step input response, determine the settling time, peak time. Oh, it's very easy, straightforward. TS, TP, steady state error. So the system is type 0 or type 1. Safwan, system type 0 ke type 1? Type R, type 2. Safwan, system type. System type.
Type 0.
Type 0. So use KP. Then use ESS. 1/1 plus KP. Okay. So come back to the solutions. Okay. So the TS TP okay. System type 0. So use KP. KP is just to 0. What is the gain just now? Ismail said the gain is 11. And the zeros S plus 3, then S plus 4, then S squared plus 4S plus 5. And so find the KP value. 11 multiplied by 3, 4, okay, multiplied by 5, 1.65. Okay. Zero point. Okay. Okay, guys. Muhammad Tauri. Okay.
Yes, doctor. Yes, doctor.
Okay.
Yes, doctor.
You speak Arabic or you speak Senegal?
I speak both.
Oh, we speak both. Okay. Can you read question number 2?
Doctor,
For me?
I got a question.
Yeah.
System type 0 tu determine tu original equation ke ataupun yang ada
Daripada from here. This one is not given. Okay. So you have to derive from the plot. Okay. Like I told you just now. Okay. So if you see this plot here, we have a 3 open loop. We have 3 open loop poles. -4 dengan -2 plus minus J1. Okay. And then 0 at -3. So GS there is S plus 3. Okay. S plus 4. Okay. And then S squared plus 4S plus 5. So now data this one, okay, is S power of 0. Okay, it's not S power of 1. It's not S power of 2. It's S power of 0. Okay, that's why the system is type 0.
So
You get it?
if pada original, if kalau ada question yang macam suruh create a new one, so ambil dia original juga macam tu.
Yep. Ambil daripada original plot tu. Because this question GS is not given. So you have to search and find and derive from the given plot. That's why you must be exposed to the past year test 1 questions so that you can see how they, set the test questions. Okay, did I answer your questions?
Yes, sir. Thank you.
All right, thank you. Muhammad Tauri, continue.
Yes, doctor.
Ikra.
Question 2. A mechanical system with a unity feedback loop is represented by the following open loop transfer function as given GS, and the uncompensated system has the dominant poles of S equal to -0.88 at 20% of overshoot. Question A, design a suitable controller to reduce the settling time, TS to become 3/5 of the uncompensated value and maintaining the same overshoot.
That's all? That's all?
Sorry,
Continue.
doctor.
Continue.
Question B, sketch the root locus of the uncompensated and compensated system and mark the location of dominant poles for each case.
Continue.
I'm not quite sure, doctor. Don't want to say something wrong.
Answer. Answer?
I'm not very sure, doctor. Sorry.
No answer. So I have to discuss the answer. Okay, so this type root locus not given. Okay. RL plot not given. So how to do it? How to do it? Benjin, how to do it?
The equation to find the poles and zeros.
Where are you? Very far away. Where are you?
VTM.
You seem that your voice from London. Far away. Cakaplah kuat sikit. Apa dia?
To get the poles and zeros from the equation.
Yeah. Okay lah. Si Michin.
Hi, doctor.
What is the root, ma?
Where?
I wait lah. I wait for you.
Okay. One plus minus square root 7j.
Simplify my square root 7.
Oh. Yeah, 2.64. Fine.
That is the zeros, eh? Zeros, eh? This one we call is a complex conjugate zero. Everybody follow me? Complex conjugate zero.
Complex conjugate zero.
Okay. Second. Si Michin, second one.
Hold on. First one is -3.
I know.
Then...
No, this one, the roots.
Okay. -2 plus minus 1j.
J1.
Okay, J1.
Complex conjugate poles. Everybody follow me. CCP, complex conjugate poles.
Complex conjugate poles.
谢谢。
不客气。
不要客气。Dominant pole sama dengan is given kan? Dominant pole given, minus 0.88 plus minus J 1.72. Okay, given 20% overshoot. 20% overshoot, how zeta value? Chong Juan?
About
20%.
20%.
Zero point 46. Okay. Zero point 46. Angle
2.61.
huh?
2.61.
2.61.
6.
Wow, so small. 62.
Yeah.
62. Point
61.
Okay. Well, how to do it? We have to find the new settling time, TSN, which is 2/3 of TSO. N for new, O for old. But TSO is 4 divided by real. 4 divided by real. This one, 0.88. Can. That's why TS new. 2/3 TSO 4.55. Okay. And from here, we can find the real one, the real new, because dominant pole, the old one cannot be used anymore. So we have to find the new dominant pole. Okay. Seven five. Okay. So zeta 0.46. Theta is equal to cos negative 0.46. 62.6. Okay. Theta kan origin. Okay. Ni y tak tahu kan. And this real part is from here, 1.75. Okay. So tangent theta okay, tangent degrees. So y is equal to 3.38. That's why new dominant pole is 75 plus J. Okay. Okay. Daniel Zulkifli, what next? Daniel Zulkifli.
Hello, here there.
What next? Second, Daniel.
Find location of dominant pole.
Ish. Pula, mana dapat tadi? Ini dapat dia apa? Find location of 0 for PD controller. Ish, budak ni. Tak faham lagi tu. Tak faham lagi. 1.75 plus J 3.38 kan? Daniel,
Yes.
what is the open loop pole? -3. Okay, again.
-5.
-5. Mana ada -5?
-2 plus J1 plus minus J1.
Betul. -3. So dia ada sinilah. Kan? Dengan betul? J 2.645 minus J 2.645. Okay. Yang ini pula yang si Mechin cakap tadi, -2 plus minus J1. Okay. And this is the dominant pole, the new dominant pole. Kan? So you have to find the angle. Okay. This one is, and then you put the zeros over here. Anywhere, assumption, anywhere. You can put on the right, on the left, okay? As long as visible on the real axis. So I name it theta C, theta controller, theta PD controller, theta C. Okay, and this one is theta 1. Okay, and this one is theta 2, and this one is theta 3. Okay, and this one is theta 4, and this one is theta 5. Okay, so you must draw this. For PD controller, you must draw this compulsory. Okay. Then uses angle property. Okay. Angle criteria. C. Poles minus zeros. 180 degrees. Theta 1 plus theta 2 plus theta 3. Theta C plus theta 4 plus theta 5. 180 degrees. Okay. So you simplify this, so you will get theta C 140.77 degrees. But 140.77 degrees is, if we look at the condition of the triangles, is over here. So we want this one, alpha. We want to know what is the value of alpha. So the length here is the imaginary axis of the imaginary part of the new dominant pole, 3.38. And this one is minus 1.75. Okay, and this one is minus ZC. So we have to find this X. Okay. Right. So what is alpha? What is alpha? Ivan, what is alpha? How to get alpha?
39.23.
How do you get?
180 minus 140.77.
So alpha is around 39.23 degrees, right? So that's why 3.38 divided by x. So x is equal to 4.13. Okay, so ZC. ZC is about 2.39. Okay, it's on the right half plane, right half plane. Zeros to the right half plane. Okay, so GPD is equal to K S plus ZC. Okay, so GPD is equal to K S minus 2.39 because the zeros on the right half plane. Okay, so how to calculate K? Ismail, how to calculate K?
We insert the point in the transfer function.
In the magnitude criteria.
Magnitude.
Okay. Magnitude criteria. So S is the new dominant pole, which is minus 1.5. So K is equal to 0.38. 0.38 S minus 2.39. Okay. So when we compare with the standard one, GPD, which is KD, S plus KP over KD. So KP over KD is equal to 2.39 minus 2.39. So that's why KD is 0.38. KP is equal to 0.91. Okay. So when we plot the locus after PD controller, okay, so this is minus 3, this is the minus 1, minus 2, minus 2, J1, minus J1, then we have a zeros over here, so what is the expected plot? And here, minus 2.39. Liana Camelia? Liana Camelia? Ada? Atra? Dia punya plotting ni macam mana? Last question. After PD.
Tak tahu dah doktor.
Tahu. Astagfirullah.
Tak sama.
Start from poles to zeros and then this one straight there. And
Okay.
Before PD. before PD. -3. Jadi -2 plus J1. Nah, dia PD tak ada. Ini adalah before. Before PD. PD tu apa Natra?
Ini
What Dixon? Proportional derivative controller.
proportional derivative.
So this one is before PD. So when we insert the PD controller, so there is a 0 over here, plus 2.39. So dia tak pergi sana lagi lah, pergi sini. Okay. Okay. Boleh Natra? Rasanya boleh buat tak?
InsyaAllah.
InsyaAllah. Okay, kalau insyaAllah, can you read this question? Just read.
Figure question 1A shows a unity feedback control system. The system is controlled using a simple proportional controller K given two open loop transfer function G1S and G2S as following. First, with the help of root locus, cache for G1S and G2S, explain the state of each system at infinity.
Okay, this one plus one sini the plus. Okay. So 0.075 S square plus S plus 1. Okay. Continue.
Second, determine the closed loop pools of the system G1S and G2S for K equal to 40. Give your comment based on the result update. B, given a unity feedback control system as shown in figure question 1B and G3S, based on the new dominant pools as shown on the root locus of the system in figure question 1C, determine the PD controller for the system GPD KS plus Z, given that the system needs to operate at damping ratio 0.59 and overshoot percentage 10%.
So now plot is given. Plot is given. So what is the value of this new dominant pool? Cuba baca pada graf. Can you read? Can you read? Satu, dua, tiga, empat, lima, enam, tujuh. I think it's tujuh. 1, 2, 3, 4, 5, 6, 7. Minus 6.99 plus J 9.56. Okay, so jot down. So please jot down this value. So I will continue to discuss this on Wednesday. Boleh, Natra? Boleh, Natra?
Boleh.
Ini last semester ni. Last semester, which is 8 of June. Oh, because last semester we only have one exam because of COVID. So only one test and 3 quiz. But this semester, no quiz. Test 1 and test 2 tests. That's why they have a delay. 8 of June 2021 after Raya ni. It's after Raya. Okay. This is last sessions and I was there. Okay. I was there. So we continue on Wednesday lah. InsyaAllah. Boleh, Natra? Ke nak sambung?
Continue next Wednesday.
Habis cepat je kau. Okay, guys. Alright. Okay, sorry to take your time. 12:52 now. So
Thank you
I
so
will
much,
give. I will share the YouTube link. You want the YouTube link? Oh, no need. Have you jot
Yes,
down everything? Huh?
Yes, please, later. That'd be great.
Who want the YouTube link? Raise your hand. Using Zoom. No need, because it's a revision only, not a lecture. Oh, everybody want huh? Si Michin. Perlu ke?
Need to look back.
Back, oh, very fast. Because we discussed 2 hours with 2 past year questions. Then we have about 9 minus 2, another 7 sets to discuss before we enter the exams on the 26th, 28. I can't remember. 26, 28 kan?
27.
27. Okay. Pukul 9 malam lepas buka lah. Makan pukul 7. Okay. Alright, guys. Thank you very much. See you on Wednesday. Bye.
Assalamualaikum, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Assalamualaikum.
Thank you, Doctor.